Oceans by Seymour Simon. Earth is different from any other planet or moon in the solar system. It is the only one with liquid water on its surface. In fact, more than 70% of the Earth's surface is covered by oceans. Although we speak of the Atlantic and Pacific as separate oceans, the world is really covered by a single body of water in which the continents are islands. Echo soundings of the ocean floor show mountains more than twice as tall as Mount Everest and canyons 6 times as deep as the Grand Canyon. A computer was used to produce this map of the land beneath the waves. Blue shows the deepest spots and yellow is the shallowest. The average depth is 2¼ miles. The main features on the map are the Mid-Atlantic Range, part of the longest mountain chain in the world, deep ocean trenches here and here, and undersea mountains that rise above the waves to become islands. There is an enormous amount of water in the oceans, more than 1.5 quintillion. That's a 15 followed by 17 zeros. Tons. That's 100 billion gallons for each person in the world. Yet the amount of water in the oceans has remained much the same for many millions of years. That is because most of the water that evaporates into the air returns to the sea in the form of rain or snow. Even the water that falls on land finally runs downhill in rivers and streams to the sea. All this water is constantly in motion, driven by the sun's energy. The sun warms the ocean waters, especially in the tropics, where the sun's rays are more direct. That warms the air at the surface of the waters, which then picks up moisture. Some of the moisture in the air condenses into clouds, releasing more heat into the atmosphere. The uneven heating causes winds that blow across the surface of the sea, producing waves and currents. These carry heat energy for thousands of miles from the warm waters around the equator to the colder waters of the polar regions. The major ocean currents of the world flow in huge circular paths called gyres. This satellite photo shows a section of the warm Gulf Stream, part of the North Atlantic Gyre. The computer-generated colors show water temperatures from the warmest, which is red, to the coldest, which is blue. The Gulf Stream swirls up the east coast of North America and out into the Atlantic at a speed of up to 100 miles a day. In the middle of the Atlantic, the Gulf Stream divides, and part of it becomes the North Atlantic Current. This flows past northern Europe, making the climate warmer and milder than it might be otherwise. In the Pacific, the warm Japan Current becomes the North Pacific Current and then moderates the climate on the west coast of the United States and Canada. Sometimes the normal pattern of ocean currents changes and the result can be a disaster. One of the world's major fisheries is in the cool, nutrient-rich waters off the coast of Peru. Every few years, however, the cool water warms and the sea life disappears. This strange change is known as El Nino. These computer-generated maps show what happens. The blues are the coldest waters, red's the warmest waters. The image on the left shows the warm currents that produce normal weather in most years. The green area shows the cooler waters usually found off the coast of Peru. The image on the right shows that during El Nino, the warm currents have cooled and the cool waters have warmed. During the winter of 1982 to 83, the biggest El Nino of the century was underway, and all around the Pacific, climates changed. Australia suffered the worst drought in 200 years, causing immense dust storms and fires. On the west coast of South America, heavy rains up to 3 times above normal flooded the region. And the United States, record snow fell in the Rocky Mountains, which resulted in heavy flooding in the spring. If you visit the shore, you'll soon notice the daily rise and fall of the water, which we call tides. Tides are caused by the gravitational pull of the moon and the sun. Even though the moon is much smaller than the sun, the moon is so much closer to the earth that its pull is much stronger. As the earth rotates, the ocean waters nearest the moon are pulled outward in a traveling bulge called high tide. There is also a traveling tidal bulge on the side of the earth opposite the moon. Here, the moon's pull on the waters is less, and so there is a second high tide. Because of the double tide bulges, most places on the coast have 2 high tides and 2 low tides every 24 hours and 50 minutes. Twice a month, when the sun and the moon are lined up with the earth, their gravitational pulls combine and produce the biggest tides, called spring tides. The sun and moon also pull at right angles to each other twice a month, and then we get the smallest tides, called neap tides. Even in places close together, tides do not always occur at the same time or have the same size. The time and size of the tides depends on the shape of the shore and the width of the gulls and bays. Think of an ocean as kind of a large, shallow pan of water sloshing back and forth. The water in the middle of the ocean moves up and down very little. The water at each end of the ocean moves up and down much more. Because of this, islands in the middle of the ocean, such as Hawaii, often have small tides compared to the lands around the edges of the ocean. If a tide can spread out, such as in the wide Gulf of Mexico, it may rise and fall only a few inches a day. When the tide cannot spread out, the tides are much greater. This photo shows an inlet in the narrow Bay of Fundy in Nova Scotia, where high tide may be 50 feet higher than low tide. Look at that. Look at these boats. They're floating, and now they're on ground, and guess what? The boats didn't move. The water did. The waves commonly called tidal waves really have no connection with the daily tides. The name scientists use for this kind of wave is tsunami, a Japanese word for sea wave. A tsunami is generated by a violent undersea earthquake or volcanic explosion. The shock forms a wave that can move across an ocean at 500 miles an hour, as fast as a jet plane. In the open ocean, a tsunami is only 2 or 3 feet high and hardly noticeable. But when it approaches a shore, a tsunami may build up to a huge size and hit with the force of a runaway train. These 3 photos show the arrival of a tsunami on the shores of the island of Oahu, Hawaii. The tsunami was generated by an earthquake 2,500 miles away in the Aleutian Islands in Alaska. This tsunami resulted in over 50 deaths and much property damage. When the wind blows across the surface of the ocean waters, little ripples form. As the wind continues to blow, the ripples grow into waves. The size of a wave depends upon the speed of the wind, how long it blows, and the fetch. The fetch is the distance over which the wave travels. The faster the wind, the longer it blows, and the greater the fetch, the bigger the waves. In the open ocean, where the wind is blowing and making waves, the waves are all different sizes and shapes and go in different directions. As the waves move away from where they began, some travel faster than others, and they form groups of about the same wavelength. The waves are now long and smooth and are called a swell. Waves moving across the ocean carry the energy of the wind, but the ocean water does not move along with the wave. As the wave passes, the particles of water move up and down and around in a little circle. If you watch a stick floating on water as waves pass by, you'll see that it bobs up and down, but it stays in just about the same place. Only the energy of the waves moves forward. The high spot of a wave is called a crest, and the low spot is called a trough. The distance between 2 crests, or 2 troughs, is called a wavelength. The height of a wave is the distance from crest to trough. So from here to here would be the height of the wave, and from here to here would be the wavelength. Storm-driven waves in the ocean can build up to great heights. The largest wave on record was 112 feet high, the height of a 10-story building. That'd be scary. Ocean-going ships can ride over most waves. Small ships can ride up one side of a wave and down the other. Large ships can usually ride through waves without too much difficulty. During a hurricane or a severe storm, however, a huge wave can dump hundreds of tons of water upon a ship in a few seconds, smashing it apart and sending it to the bottom. When an ocean wave reaches the shallow water of a shore, it begins to travel more slowly and its shape begins to change. Some people say that the wave begins to feel the bottom. Waves begin to pile up and grow higher as those in the back come in faster than those in the front are moving. As the waves slow down, the crest of the wave tries to continue at the same speed until finally it topples over into the trough of the wave in front and becomes a breaker. When waves break on the shore, the surf begins. Sometimes surf can break just a few yards from shore. However, if the shore is shallow, surf can form hundreds of yards out to sea. The waves on shallow beaches, such as this one in Hawaii, spill over slowly as they roll up the shore. Even rocky coastlines are worn away by the power of the surf. The softer kinds of rock are worn away first, leaving rocky spires or platforms of harder rock. These too will eventually be worn down by the pounding of the waves. In other places, the incoming surf carries sand particles from one spot to another, slowly building up beaches and dunes. Every moment of every day, the sea is at work reshaping the land. Isn't it beautiful? Many years ago, life began in the sea. Today, the sea is home to incredible numbers of living things, from microscopic plants and animals called plankton to giant whales larger than any dinosaur. Some animals are drifters, others swim freely, and still others spend their entire lives on the bottom of the sea. One way or another, all sea animals depend upon the multitudes of tiny plankton plants, which drift in the surface waters of the ocean, using the energy of sunlight to produce food. The tiny plants are eaten by small fish and other animals, which are eaten by large animals, and which are eaten in turn by even larger animals. Many tons of sea animals of all kinds are eaten each day by people all over the world. Throughout the ages, the sea has been the inspiration for art, music, and poetry, as well as a source of food and a highway to travel. The sea has also been used as the world's wastebasket for garbage and even radioactive wastes. Until now, the sea has always been able to renew itself. But we are reaching the limits of this vast ocean world, and without the sea, the earth would be a world without life. Thanks for joining me.